Good morning, all of you.
Good morning, sir.
Good morning,
Good
sir.
morning, sir.
Good morning.
Yeah, yes,
Good
actually,
morning, sir.
yes. See, today we all are going to do our first experiment. Okay, that is Hall effect. Okay, so right now I'm going to, that means present the experiment first, how to perform the experiment, everything I'll tell you. Then after I'll be online, you just start taking observations. Okay, it will it is a very easy experiment. Within 15 minutes, you all can complete this one. Okay, but you need to submit the record. That means by making the PDF before due date. Okay, that is your before next class. You have to submit this experiment number 1. Okay, then after we will start experiment number 2 in next class.
So in a
See,
week we will have one class or two class.
yes,
In a week we will have one class or two class.
1 class. Okay, that is on Tuesday only. You all are, that means you have a class on Tuesday, that is 10 to 1. Okay,
Okay, sir.
yeah, clear. Right now, I'm going to present my screen and give some idea how to write the records, how to perform the experiment, everything. Okay, so right now I'm going to present my screen first. Okay, my screen is visible.
Yes, sir.
Please reply.
Yes, sir.
Yes. Okay, fine. See, this is the experiment. Okay, fine. Hall effect. Experiment number 1. See, the first one will find one link, that is BLAB simulator link. After clicking this one, we'll go to the experiment. You just observe. Okay, this is the experiment. How to perform the experiment, I'll say later. But before that, you just check other things. Then how to write your fair record. Okay, first of all, you have to write the aim of the experiment. For aim of the experiment, okay, you have to follow which PDF, that is also written. Hall effect 01.pdf. You just find, we have 3 PDFs. Okay, this is Hall effect 01.pdf. You just open that one. Then we will find the aim of the experiment. These two are our aim of the experiment. To determine the Hall voltage developed across the germanium material. And second one is to calculate the Hall coefficient and the carrier concentration of the material. Okay, fine. Okay, then after go to the next thing. What is that? Then after you have to write what apparatus required. For apparatus required, see the attached file Hall effect 02.pdf. You just see. These are the apparatus. Okay, 2 solenoids, constant current supply, 4 probe, distal gauge meter, Hall effect. These are the apparatus required to perform this experiment. We have. Okay. Then after apparatus required, what to write? You just check theory part. For theory part, which PDF you have to follow? 02.pdf. Open that one. These are the theory. And you need to draw this diagram or figure also. Okay. Continue writing theory part. Okay. This much. Okay, then after this theory, you need to write what? Procedure part. But do one thing, see, actually what is the procedure part? And we are going to already written there procedure for simulation. Okay, actually you have to follow 03.pdf. Okay, I'm showing you. Here you will find 2 procedures. One is procedure for real lab. This part you have to write. Procedure for doing the simulation. These are the procedure part. Okay. Continue writing. Okay, these tables are not required. Okay, these tables actually in PDF 1 you will find these are the observation tables. Okay, okay. We will take observations in this table. Actually, I'll show you. You may take in rough note only. Okay, no need to write in rough fair copy. What is the reason? I'll say. Then these are the things. You have to write the procedure part. Then after go for observation and calculation, which PDF? 01.pdf. Then write the discussion, then conclusion, then write acknowledgement part. Okay, you all clear about acknowledgement or not? Please reply.
Yes, sir.
Yes.
Yes, sir.
Yes,
Okay,
sir.
fine. Then after writing the acknowledgement part, you have to put your name and ID. Okay. Then just by scanning all your record, okay, make a PDF and submit to Google Classroom before due date. Already written here What we are finding here? Due date. Got it?
Yes, sir.
Okay,
Yes.
fine.
Yes,
So
sir.
before this due date, you all should submit this one. Otherwise, your submission will be marked as late submission, against as a result of which your marks will be deducted. Okay, so just avoid that thing. You just 1 week is sufficient. Within 1 week, just go and submit. Okay, fine. Then after, initially you just take your rough notes, and using your rough notes, you need to note observations. Then after, start writing. Complete the observation and calculation also in rough. Then after, you need one on graph page to complete this experiment. Okay, then complete everything and make a PDF and submit to Google Classroom. Fine. So right now I'm going to how to perform experiment. I'll say. See, first of all, actually see the observation tables I'm showing you. See, suppose this is observation table 1. Okay, what is written, what are the constants? First of all, actually in Hall effect experiment, what we are doing? We are doing the experiment for a given germanium crystal. Okay, so here, so we have a crystal. So first of all, what is written here? See, T is equal to 0.3 mm. That is, thickness of the crystal is 0.3 mm. You have to make select. Then B is equal to, actually B is what? Magnetic flux density of the electromagnetic field. So it should be constant throughout for a single table. That is for table 1, 0.1482 Tesla. Okay, then E is given. Then after you need to change Hall current with the interval of 0.5 milliampere. Then you need to note Hall voltage, VH in millivolt. Okay. Then after, this is the formula to calculate RH. RH is what?
All resistance.
Resistance.
Yes. Okay. So you need to resistivity. You have to calculate using this formula. VH you will find from this column. Then T, which is given. Then I you will find from here, and B is constant. Okay. Then after, you have to find carrier concentration. That is N. Okay. One is Hall coefficient. Then after, this is the carrier concentration. You need to calculate these two. Then after, go to table 2. In table 2, you just check. T is same with table 1, but B is different. That is 0.2964. How to change? I'll say. You just make sure first. Then is, yes.
वो सर शार्ट करना को तो पाइन कट करना शील्ड होना
What happened?
అనుగా అనుకిన పచ్చా బుక్ చేసుకున్న 2 గంటలనే సిలిండర్ కన్ఫర్మ్ కోతరా సార్
Click mute button. All of you. Okay.
Sir,
See.
I think you can mute all the participants.
Okay, fine. See, so right now, these are the things. Actually, you need to make it constant first, then note down the observation. See, in table 1 and table 2, you will notice one change. So for table 1, B should be 0.1482 Tesla, and for table 2, B should be 0.2964 Tesla, and thickness is same. Okay, you need to change accordingly. Okay, actually, we are doing experiment for two magnetic field. That is, one is 1.1482, other one is 0.2964. Okay, you just see also table 5, 0.1482 and 0.2964, table 6. For table 5, table 6, for table 5 and table 6, T should be 0.8 mm. Accordingly, table 3 and 4, T is 0.5 mm, and table 1 and 2, T is equal to 0.3 mm. Okay, so right now I'm going to the experiment. Okay, see, first of all, you have to select magnetic field versus current. Okay, then after, select insert probe. Then after, click on the wood. Okay, so right now, see here, when 1 ampere current is flowing through the solenoids, okay, so the magnetic field generated, what is the magnetic flux density? That is 0.1482. That means for table 1, table 3 and table 5. So this current, okay, just check the current in 1 ampere. Here 1 ampere current, and here you have to change the Hall current with the interval of milliampere, 0.5 milliampere. Here 1 ampere. For 1 ampere, we are getting 0.1482 Tesla. That means for table 3, 1, 3 and 5, current should be 1 ampere, this current. Remember this. You may note this. Then after another magnetic field, what is the value? 2.2964. Okay, you just change the current. 1.5 we are not getting. You change that one to 2 ampere. That means 2 ampere, that is 0.2964. That means for table 2, 4 and 6, this current should be 2 ampere. You have to set the current 2 ampere and note down the observations. Okay, by changing all current, you have to note the hall voltage. Got it or not? For table 1, 3 and 5, this current through solenoid should be 1 ampere, and for table 3, so 2, 4, 6, this current should be 2 ampere. Okay, you have to change it accordingly. Then after go to table 1 and change this procedure is Hall effect setup to Hall effect setup. Then after click on insert Hall Pro, then click on the wood. Okay, right now what it is showing? What it is showing? 1 what? 1 milliampere. That means it is showing the Hall current. Okay, got it? That means when you change the procedure to Hall effect setup, we will not find what? Magnetic flux density, Gauss meter, will not find. But already you know, right now, what is the magnetic flux density for 2 ampere? That is 0.2964. But we need to perform the experiment for 1 ampere. That means when you are selecting 1 ampere, so automatically the magnetic flux density should be 0.1482 Tesla. Clear or not clear?
Yes, sir.
Yes,
For table 1, 3 and 5, it should be 1 ampere. Okay. Okay, and procedures. Okay, what to select? Hall effect setup. Because right now we are going to note the all observations. Okay. Then after completing observation for 1 ampere, that means observation 1, you need to go to change the current to 2 ampere. Perform the experiment for table 2. Okay. See, and already I told you we are going to do the experiment for a germanium crystal. So it should be germanium only. And the thickness is 0.1, but we are going to thickness should be for table 1, thickness should be how much? 0.3 mm. Accordingly, you have to select. Any difficulties?
no, sir.
Nothing?
No,
Okay,
sir.
you all clear? In this way, you need to change the magnetic field first, then after thickness, then after Hall current. So you have to start from Hall current. Okay, 1 milliampere. For 1 milliampere, how much voltage we are getting? You need to find out. How? By clicking the show voltage. Okay, show voltage. Just click the show voltage. Right now, it is giving what? 9.585. What is the unit?
Millivolt.
Millivolt. Okay. Then after once again, you need to change the current to 1.5. Okay. Here also, you can show the current 1.5 milliampere. Then click the show voltage and write it accordingly. Then after change the current to 2 ampere, 2 milliampere, 2.5 milliampere, 3 milliampere, up to what? 5 milliampere you need to check. Okay, clear?
Yes, sir.
Yes,
So after that means you all just by changing this Hall current, you got the Hall voltage for different Hall currents. Then after by using the formula, first of all you have to find out Hall coefficient RH, then after N. Okay, using the formula. Table 1 over, then go to table 2. Okay, in table 2, what to do? First of all, you have to check the thickness. Thickness should be 0.3 and B is 0.2964. That means you need to change the current through solenoid to 2 ampere. Okay. So for 2 ampere, we are getting what? 0.296 per Tesla. Then thickness should be same and you need to change the Hall current from 1 milliampere. Okay. For 1 milliampere, we are getting voltage now. Okay. It's lighting. So when you just click show current, so this milliampere is lighting. Okay. Got it or not?
Yes, sir.
Then after
Yes, sir.
in this way, you need to do the observation table 2 over. Then go to table 3. For table 3, what is the thickness? Thickness should be 0.5 and B is 0.148 Tesla. So how to select? Just go to the experiment and you need to select accordingly. That means your 1 ampere this one and this one is 0.5. Done? Okay? Please reply.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then
Yes,
after you
sir.
need to change the current only and note down the corresponding hall voltage. Fine or not?
Yes, sir.
Yes, sir.
Sir.
Yes,
Okay,
sir.
yes. Then after see, one more thing is there. That is table 3 over, then go to table 4. Okay, 0.5 and 2.2964. Then for table 5, that is 0.8 mm and 1 ampere current. Okay, that is first table for 0.148 Tesla. Then make the current to 2 ampere and thickness to 0.8 milliampere. Okay, after noting all observations for all 6 tables, then what are the instructions? You just see. Plot hall voltage versus hall current of above observation in single graph sheet. Okay, take a single graph sheet. On that graph sheet, you need to plot a graph. Okay, but how many graphs? 6 graphs. That means you will find 6 lines there. Okay, that means you have to take hall current along x-axis and hall voltage along y-axis. You need to plot graphs. We'll find 6 graph. Okay, and find slope from all graphs. Then using those slope, you need to calculate RH, then A. Got it or not? Please reply.
Yes, sir.
Yes, sir.
Okay, on the what? You have to plot all graphs on a single set. Okay, that means how to take the scales. See, x-axis scale same, but y-axis scale you need to vary. So do one thing. First of all, check observation 1 of, okay, hall voltage. Table 1 first observation, because this is the minimum one, and table 6 last observation, which is the maximum voltage. So accordingly you have to set the scales, then you need to plot the graphs. Clear or not clear? Please reply.
Yes, sir. Clear.
So right now, okay, I'm going to stop presentation, then you just continue noting observations first in drop copy. Okay, if you are facing any problem, you need to ask me. Okay, I'm online, no issues. You just perform the experiment. Okay,
Okay.
so right now I'm
Okay.
going to stop presentation. You just continue noting observation first. Then after I'll take the attendance. Okay.
Okay.
अबे पागल Excuse me, sir.
Yes, tell me.
Sir, select सर सिलेक्ट मटेरियल में नहीं हो रहा है.
What? Select material.
Yes, sir.
Which one? This one. When you see, you just share your screen. Okay.
But
You just share your screen.
sir,
Yes.
it is mobile phone. On mobile phone, it is not actually working.
Okay. Too difficult to perform the experiment in mobile. Okay.
Yes, sir. Actually, on laptop, it is essential, I think.
Okay. That is the reason. Actually, see, so I'm repeating once again. When when the procedure is Hall effect setup, in Hall effect setup you can change the material. But when you are selecting, that is magnetic field versus current, you can change the material. Okay,
Yes, sir.
continue.
Excuse me, sir. Are the RH by E or 1H
Which one? Let me check.
in carrier concentration?
1 by
Yes, 1 by ERH. Okay.
Yes, sir.
Sir,
Yes.
I am sharing the.
RH is resistance, right?
Yes. That is your Hall
And
coefficient. Okay.
oh, okay.
Hall coefficient. Okay.
Okay, sir.
RH. Yes.
Sir, I am
Yes.
sharing the screen, but not
Oh,
able to select material.
you just share what? That is your experiment lab. Yes. Okay. Not able to select material. So, okay, you first use change the procedure to Hall effect setup. Hall effect. First change the procedure to Hall effect. Then after you can change the select material. Then start the experiment. Then go to select material. Okay, fine. Clear or not clear? Did they reply?
Yes, sir.
Okay, stop presentation and continue noting observation.
Sir,
Okay,
how to
fine.
check the magnetic induction?
Okay, actually that is already you got for 1 ampere current.
Yes, sir.
For one, for observe what is the magnetic field? That is 0.1482 Tesla. And remember, for 2 ampere current, we are getting that is 0.296 for Tesla.
Right.
So accordingly, you need to select. But here procedure should be Hall effect setup. Okay. So
Yes, sir.
if you want to check the magnetic flux density only, so then go to the magnetic field versus current. But that is not the experiment. In that, you can check the magnetic field. For what current? What is the magnetic field generating? Okay, that
Okay,
you.
sir.
Okay, continue noting observation.
Thank you.
Yes. Yes, tell me. Yes. भैया समझ में आया, वो तो समझ गया, लेकिन उसे अभी तक लिंक नहीं गया है, तो उसका आईडी कितना है? $69, huh? So just inform him to join as outsider. So for this class, I will accept, admit that one. Then after I will send the link, okay? Okay.
Sir, in the Hall effect resistance,
Yes, Rosal, tell.
sir, in the Hall effect resistance, we will be using that 1 ampere current or the Hall effect current.
Hall current, that is not the current. So that is current through solenoid. You need to see for different observation, different current. That means for first observation, current is 1 milliampere. Second, 1.5. Third, 2. Got it or not?
Yes, sir.
Okay. Against which you need to calculate. So that is the current through solenoid. Okay.
Sir, calculation is coming in the show result section. Sir, do you have to manually calculate it or just write it?
No, you need to calculate. Don't show result. Click show result. Okay. You just calculate yourself. What you are getting, you will get the same thing. Okay. You will get the same thing. No issues, but you need to calculate. Okay.
So how to do experiment for next magnetic field, that is 0.28 something. Hello, sir.
Change the current to 2 ampere.
Sir,
ampere, yes.
we'll change the
Okay.
current to 2 ampere.
Yes. That is the thing. Actually, you just change the current to 2 ampere. Which current? 2 ampere. That means current through solenoid. That means when you
Yes,
are
sir.
going to change the current through solenoid to 2 ampere, against 2 ampere current, will get a magnetic field of 29.296 Tesla. Okay, got it or not? Continue noting observation.
Yes.
Okay, just listen. Someone is asking about Vivek Misra. Samir, you are asking? Vivek Misra, you just provide the email, okay? Institute mail ID of Vivek Misra. Yes.
Sir? Hello, sir.
Yes.
Sir, that if we are wearing the hall current, we are getting the hall voltage up to 3 places of decimal.
Yes, right,
So
accordingly.
we will
Yes.
plot that in the graph. So how we will plot it in so accuracy?
That already I told you. See, you just see. First of all, from of table 1, observation 1, you will find the
Yes.
minimum hall voltage. And from
Yes.
table 6, last observation, you will find the maximum hall voltage. So accordingly,
Yes.
you have to take the scales. Okay? Got it?
Okay.
Got my point or not?
Yes, sir.
Accordingly, you need to take the scales. Then you just plot accordingly. No issues.
Yes,
Okay?
sir. Yes.
Yes. Try to plot. It is fine.
Okay, sir.
Get the result. Sure.
So voltage observations are noted.
Okay, then go to plot a graph. Okay, so all 6 tables completed.
Yes, sir.
Okay, start plotting graphs, sir. Okay, then after I'll take the attendance.
Sir. Hello, sir.
Yes.
सर प्रोसीजर में जो PDF 3 से स्टार्ट करना है उसमें हमें ये बटन इंसर्ट प्रोब वो उसमें समझाना है.
No, actually you just change the procedure in your own words. Okay, so what you did, you just write accordingly. No issues.
We
Okay,
don't
10
have to
lines,
write what we don't have to explain slider क्या
Then
करता है.
no, yeah. Actually, what you did, that you have to explain in your own words. Clear or not clear? No need to
Okay.
copy the same thing from the PDFs. Okay.
Thank you, sir.
Yeah, actually those are the instructions. So by following those instructions, you did the experiment. So you need to change yourself. Okay.
Thank you, sir.
Excuse me, sir.
Yes.
Sir, the diagrams we have to draw on the plain side of the paper or on the ruling.
Obviously, yeah. Ruling side, how to draw figures. Okay. So
Okay,
for
sir.
figures, use white side. Okay.
Okay, sir.
Yeah.
Sir, we did an experiment now, sir, in lab.
Yeah. So no need to submit that one in that means using Google. You need to actually after completion of all 7 experiment. Okay, we managed to submit the hard copy to the lab. At that time, you just submit that one. Okay, 8 experiment. Okay, fine. If you completed, submit that one also.
So our equipments are not working, sir, in that one. I didn't notice
Okay, you
because
just ignore that one. Okay, you just ignore that one. When suppose after 1 month we are starting once again your physical lab. At that time, I'll take care of that. Okay.
okay, sir.
Okay.
Excuse me, sir.
Yes.
Sir, did you add me in the classroom because it is not visible in my classroom box?
So what is your? You just give the email. Okay. So I'll send a link right now. Okay. I'm going to send. You just tell me the email. Just
Sir,
wait 1 minute.
sir, I don't know your email ID.
Actually, you don't know your email ID. College mail.
Sir, I don't know yours. I do know mine.
You just tell me. No need to send me. Okay.
Yes,
That I told.
sir. It's B121069.
Okay. Just 1 minute. I'm going.
Okay, sir.
What is B?
B121
121
069
069 @
triple IT-bh.ac.in.
Sir, video is not visible in my account also.
That is link is not there.
No, sir.
So what is your ID?
B121003.
Okay. B
121003.
121003.
Sir, in my account also there is no sign of video.
Sir, in my account also no video, sir.
Okay. So what is your ID? Just tell.
B121021, sir.
12 10 21.
21.
One more is there, sir.
Yes, tell me.
B121 059.
9.
69.
Sir, B121061.
B 121
061.
061.
Yes, sir.
Sir, B121064.
Actually, it is already shown that already shared. Okay, already link shared to you.
Sir, B121 059.
Just 1 minute. I got an error message. Couldn't invite 4 students. That is 003 and ID 21, 59 and 61 also. Okay. For Vivek Misra, it's okay. But for others, it is not. Couldn't invite 4 students. It is showing. What is the reason? I don't know. Actually, it is showing invitation already shared to you. You just check yourself. Okay.
Sir, we are added in the classroom, but the video link is not there.
Which link? That means when I am presenting, you are not getting anything.
No, sir. We cannot join the Google Meet from the classroom. We always have to ask our friends for the Google Meet link.
Okay, I got that one. Because already shared. You just try to check your mail and try to join the classroom once again directly. Because I already shared to you, link shared to you. Okay. It is showing in my system.
Okay, sir.
Okay, Vivek, you got the link. You got the invitation, Vivek. You just check yourself.
Okay. Yes, sir. Yes.
Got it or not?
Sir, ID number B1210.
I'm just checking, sir.
Okay, you just check yourself.
Sir, another numbers.
Yes?
B121016.
16.
Yes, sir.
Okay, let me check once again. B12116016.
Sir, 035 also.
Yeah, let me check.
035 also, sir. B121035.
16.
Excuse me, sir.
Yes.
Sir, 060 also.
Okay, I'll make a list, then I'll check once again. Okay.
Okay, sir.
After class, I'll check. Okay. Tell me B2121 016 B121 060. You told na?
Yes, sir.
Then any others? You just tell me.
Sir, 035.
035. Then
Sir, 034.
034.
Sir, 051.
Sir, 021.
051 021. Okay.
Sir, 042.
042.
Sir, 003. I have tried to read it.
Okay, 003.
059.
059.
061. Sir, 011.
061 011. Okay.
Yes, sir.
Any more? 011. Ansuman, what's your name? One is showing Ansuman Padi invited but not joined. Then others, let me check. Those. Others joined. Okay, I'll check this one. Vivek Mishra invited. Okay, it is showing right now. Vivek Mishra invited. Okay, this much or any more left? 016 060 035 034 051 021 042 003 059 061 011. Okay, I'll check that one. Okay. Okay, your observations over. Are I
Yes,
forgot
sir.
the observations?
Yes,
Yes,
sir.
Right now I'm
Yes,
going
sir.
to take your attendance. Okay.
So I
I
have a
will.
doubt वो graph के
Yeah.
लिए.
Okay.
So we
Tell
have to
me.
make 6 separate graphs for each
No,
table.
no. On the same sheet. Okay. You just take see. For along x-axis, you need to take what? Your hall current, which is same for all or not? You just reply.
Yes, sir.
But along y-axis, okay,
Yes,
when
sir.
we are going to take along y-axis what? Hall voltage. We will find the minimum hall voltage from the table 1, observation 1. And we will find the maximum hall voltage from which observation? Last observation of
Sixth.
table 6. So accordingly, you need to take the scales. Okay, 1 unit is this much.
So
Then after you need to plot 6.
Maximum hall voltage is coming from table 3. Sorry.
Table 2.
It's coming from
Okay, you just
table
check
2.
yourself. Okay, fine. You just check yourself. What you are getting, accordingly you need to plot. Okay, because you are changing the thickness, na? That is, ignore that one. Okay, accordingly you need to check the scale. Suppose you got first one is 10 and last one is 100. So you have 20 units. You just divide accordingly. Each unit is equal to 5. Okay, fine, done. Got it or not?
Yes, sir.
Please reply.
Yes,
Okay.
sir.
Yes, sir.
In this
Yes,
way,
sir.
you need to plot the graph. Then just find the slope of the graph, and by putting the slope, calculate RH, and then carrier concentration. Okay. Then right now I'm going to take your attendance. Okay, I will call your IDs. You have to reply by telling.
Sir,
your
sir,
name.
we will write the calculation means loop in calculation section.
Yes.
Okay, sir.
Okay, ID 1,
Present, sir.
2,
Present, sir.
3, 4.
Present, sir.
Sir, 3 present, sir.
Yeah, okay, present. 4, 5,
Present, sir.
6,
Present, sir.
7, 8,
Present, sir.
9,
Present, sir.
10.
Present, sir.
What's your name? Just tell your name.
Sir, Aksa
11,
Lakra.
11.
Yes, sir.
What's your name?
Ayush Singh.
12,
Karthik present, sir.
13,
Vanishankar Murmu present, sir.
14,
Bobby Desire 100 present, sir.
15,
Sutej present, sir.
16,
Present, sir. Tarun Kumar.
17,
Eugene present, sir.
18,
Rishikesh Gavane present, sir.
19, 20,
Harsh Lohana present, sir.
21,
21 Vishal sir present, sir.
22,
Jyotideep Acharya present, sir.
23,
Upendra present, sir.
24, 25,
Kirti Padi present, sir.
26,
Pratyush Kurai present, sir.
27,
Mayan Pradhan present, sir.
28,
Meenakshi Sahu present, sir.
29,
Sir, Monalisa.
30,
Mridul Tripathi present, sir.
31,
Naishakika present, sir.
32,
Nitin Sinha present, sir.
33,
Harshit Reddy present, sir.
34,
Navyapreeta present, sir.
35,
Pawan Kumar present, sir.
36,
Pravanjan Mishra present, sir.
37,
Pratik present, sir.
38,
Pratyush present, sir.
39,
Prayash present, sir.
40, 41,
Present, sir. Ravi Kumar, sir.
42,
Present, sir. Ravi Shovesh.
43,
Riddhi Agrawal, sir, present, sir.
44,
Rituparna Sunamati present, sir.
45,
Rohan present, sir.
46,
Roshan Das present, sir.
47, 48,
Rudransh Agrawal present, sir.
49, 50,
Samdel Biswal present, sir.
51,
Sir Sanjeev Sethi present, sir.
okay, 52,
Saroj present, sir.
53, 54,
Sorry, sir.
Shivashi.
53 Satvik present.
53 present, Satvik.
Yes, sir. Mic is not working.
54, okay, 54,
Shivakshi Singh present, sir.
55,
Shobhan present, sir.
56,
Shruti present, sir.
57,
Sneha Mandal present, sir.
58,
Somesh present, sir.
59,
Sudhanshu Kumar present, sir.
60,
Suman Preeti Gilba present, sir.
61,
Aman Sharma present, sir.
62,
Anuj Baloria present, sir.
63,
Rudraksh Gupta present, sir.
64,
Sahil Rishi present, sir.
65,
Swam Siddharth present, sir.
66,
Tanmay present, sir.
67,
Rafni present, sir.
68,
Ujjwal Kumar present, sir.
69,
Vivek Mishra present, sir.
70.
Sir Yogesh present.
Okay. Anyone left?
Sir, actually, roll number 40, Priyambada Omkar, she is present. Her mic is
Okay.
not working. She
I got
read-
that one. I got that one. Okay. Okay, fine.
Yes.
Okay, that's all for today. Just you completed everything, then just making graph, then find the slope, plot graph, then find the slope, then calculate once again. So in that calculation, you have to write accordingly. For table 1, you got RH is this much and N is this much. For table 2, calculate RH and N. Table 3, RH and N. Table 4, then table 5, table 6. Okay. Then we need to write discussion, then conclusion, then acknowledgement, then write your ID and name and submit to Google Classroom by making PDFs. Okay, done. So that's all for today.
There are,
Okay. Yes, tell me.
so there are a total of 2 graphs you have to plot. One for
Only one graph.
okay, and the RH for all the tables.
Okay, actually you have to put the slope only. Okay.
Okay, thank you, sir.
Okay, after getting RH, then you have to calculate N. Okay, done. Okay, that's all for today. Then in next class we'll start the second experiment. Okay, fine. Right.
Thank you, sir.
Excuse me, sir.
Okay.
Thank you, sir.
Sir, thank you, sir.
Yes, tell me.
Sir, excuse me, sir. So,
Yes.
what do we have to write in the discussion part?
Discussion part, what you did in the experiment. Okay, so what is the result you got, all these things. And same thing also you have to write in the conclusion part. Not the same thing.
In how many
In
lines do
conclusion
you have to
part
write
only you need to write the results. Finally you got the results like this. R is this much, N is this much. For discussion part, what you did in the experiment, you need to write the discussion part.
Sir?
Discussion part. Yes?
Sir, 47 present.
47.
Yes.
47. Okay, let me check. Yes. Anyone left?
Sir, 24, sir. I am in the village. Network is issue, sir.
24. Okay, fine.
Sir, 24.
Okay. Yes.
Thank you, sir.
Okay, fine.